Hello friends, welcome to Daring Marana YouTube channel. Today we will be discussing about lead acid battery, their working, construction and charging and discharging. Lead acid batteries are leading in the marine industry because mainly they are cheap and have large current and surge capability. So what are the basic components of a lead acid batteries are positive plate, negative plate, separator and electrolyte. Positive plate, this is covered with a paste of lead dioxide, and negative plate made of sponge lead. And separator means it's basically an insulating material. Between the two plates, they allow electrolyte and ions in it to enable conduction without the plates touching. So they made as just separating insulating material. Then electrolyte means this consists of water and sulfuric acid. These constituents are all contained within a plastic container. Like we can see. So you can see negative plate, that is sponge lead, electrolyte, that is like I said, water and sulfuric acid, separator, that is insulating material, and positive plate, that is lead dioxide. Then totally it is inside a plastic container, that is battery case. The overall battery will normally consist of several cells placed in series to give required voltage that is capable of providing an EMF of 2 volt. Usually in ship, like I said, 24 volt DC, so 12 will be there. Here we can see there are negative terminal and positive terminals, and separators are there, and in between the battery electrolyte consists of water and sulfuric acid will be there. So the working, the diluted sulfuric acid, that is H2SO4 molecules will break into two parts. They will be break down and dissolves in it. It will create positive ions 2H plus and negative ions SO4 minus, as I told before. So these two electrodes are connected as plates, that is anode and cathode. Then anode catches the negative ions and cathode attracts the positive ion. So this bonding in anode and SO4 minus cathode with the 2H plus interchange electrons, which will further react with H2 and water and diluted sulfuric acid or sulfuric acid and water. So this is the working, means diluted sulfuric acid H2SO4 will be breakdown and dissociates into positive ion 2H plus and negative ion SO4 ions, and these two electrons are connected as plates, that is anode and cathode. And anode will catches the negative ion, then cathode will attract the positive ion. So this bonding in anode and cathode will interchange electrons, will further react with H2O or with water. That's the working. That's what happening inside the lead acid batteries. So as a charging, what we do? To charge the battery, we need to apply a voltage greater than terminal voltage. For example, to charge a 12.6 volt battery, we can give 30 voltage can be applied. So here also charging, same chemical reactions are happening, means when battery is connected with charger, sulfuric acid molecules break into two ions, that is positive 2H plus and negative SO4 minus. The hydrogen exchanges electrons with cathode and becomes hydrogen, and this hydrogen reacts with PbSO4 in cathode and forms sulfuric acid and lead. On the other hand, SO4 exchange electrons with anode and become radical SO4, and SO4 again reacts with PbSO4 of anode and creates lead peroxide and sulfuric acid. So this means hydrogen dissociates and form a reaction and finally having a product of H2SO4. Same, in that lead again will form SO4. On the other hand, it will combine with lead and form PbSO4 and H2SO4. So this energy gets stored by increase in the gravity of sulfuric acid and increase in the cell potential voltage. So like we say in the as a formula here, what happens at anode, PbSO4 plus 2H2O will give 2PO2 plus SO4 2 minus plus 4He minus plus 2 electrons. And in cathode, PbSO4 plus 2 electrons will give Pb plus SO4 2 minus. So overall we can calculate this 2BSO4 plus 2H2O, because 2 electrons we can cut, then 2H2O will give PbO2 plus Pb plus 2H2SO4. This is the combined overall equation we can get from this equation. That means 2PbSO4 plus 2H2O will give PbO2 plus Pb plus 2H2SO4. So here the product means H2SO4 is forming here. Discharging means the sulfuric acid is usually diluted in a ratio of 3:1 with water and sulfuric acid. When the loads are connected across the plates, the sulfuric acid again breaks into positive ions, that is dissociation will be happen 2H plus 2H plus and negative ions SO4 minus. So the hydrogen ion reacts with PbO2 and make PbO and water H2O. So this PbO starts reacting with H2SO4 and creates PbSO4 and H2O. On the other side, SO4 minus exchange electrons from Pb and creating radical SO4 which will further create PbSO4 reacting with Pb. So here what I say is discharging means here dissociation will be happen. Usually sulfuric acid is diluted in the ratio of 3:1, but here it will again break down and into H2SO4 will break down to 2H plus and SO4 minus, and this hydrogen ion react with PbO2 and make PbO, and water will form with H2O. So PbO start reacting with H2O4, create PbSO4 and H2O. On other side, SO4 minus exchange electrons from Pb, thus creating radical SO4, which further creates PbSO4 reacting with Pb. So this is what dissociation and happen, and again formation happen inside the cell during the discharging process also. So let's see what the anode and cathode creation what will be. At anode there will be PbO2 plus SO4 2 minus will gives plus 4H plus minus plus 2 electron will gives PbSO4 plus 2H2O, and then it will, that means discharge the same except opposite. At cathode means Pb plus SO4 2 minus will gives PbSO4 plus 2 electron. So overall will be PbO2 plus Pb plus 2H2SO4 will gives 2 PbSO4 plus 2H2O. So this will be the exact opposite of what happened, reversible process of discharging and charging and all. So this is the thing that what happening in the lead acid batteries. Thank you.